Good morning, good afternoon, or good evening, everyone, depending on where you are. Welcome to today's webcast, Intelligent Flash, Helping Enterprise Apps Run Faster. It's brought to you today by Data Center Acceleration, a website that I run, Information Week Financial Services, and LSI, and it's broadcast by United Business Media, which is a British firm. I'm John Verity, Editor-in-Chief for Data Center Acceleration. I'll be your moderator today. We have just a few announcements before we begin. We'd like to just go over a couple of logistics questions or issues, just so you know what's what. The webcast contains audience polling. This means that a polling question will appear in the slide presentation window. Please complete the poll when they appear and click on the Submit Answer button located on the polling slide window. We thank you in advance for your participation in these polls. They're very interesting and helpful. You can participate in the Q&A session by asking questions at any time during the webcast. All this requires is that you type your question into the Ask a Question text area below the window and then click the Submit button. At this time, we recommend you please disable your pop-up blockers. Finally, the slides will advance automatically through the event. You may also download a copy later by clicking on the Download Slide button located below the presentation window. If you have any technical problems, please visit our Tech Webcast Help Guide by clicking on the Help link below the media player. In addition, you can also contact our technical support helpline, which is also located in the Webcast Help Guide. Let me introduce our speakers. We have George Crump, who's Chief Steward, he calls himself, at Storage Switzerland, the name referring to the neutrality of his observations. George is president and founder of Storage Switzerland with 25 years of experience designing storage solutions for data centers across the U.S. He's seen the birth of many different storage technologies, including RAID, NAS, and SAN. Prior to this, he was CTO at one of the nation's largest storage integrators, where he was in charge of technology testing, integration, and product selection. Gina Geisel is Principal Technical Marketing Manager at LSI. With more than 14 years of storage experience, she leverages her understanding of the storage industry, product marketing, and OEM partnerships currently as a Principal Technical Marketing Manager with LSI's Accelerated Solutions Division. Previously, Gina was the Product Marketing Manager with LSI's Ingenio Division, an OEM Channel Marketing Manager with Quantum Corp, and a Product Manager for Ingram Micro. Let me just tell you a little bit about Data Center Acceleration. It's an online community of IT executives and IT professionals in the financial services sector and others, where we discuss all sorts of things that go into making applications go faster, from chips to storage to software design to system tuning to database architectures and so forth, and we invite you to join us. The first slide we're going to show here is of a survey that was done. We've done a survey of about 117, I believe, financial services companies and almost 100 other kinds of companies in other sectors. The financial services companies were $500 million and up in revenue, and so they're substantial companies. And we asked them what are their current usages of flash memory storage and what are their plans, basically. That's the outline of the survey. And basically we found that, as you might expect, financial services companies were the leaders in this. They're far ahead in using flash memory storage of all kinds. You can understand why, of course, because they're at the sort of leading edge of IT and always have been. More than 77% of them, it turns out, are using 500 gigabytes or more of flash memory storage in one form or another. And by the way, the survey was about their use of flash memory in the data center, not on laptops and things. But only about 2% of these financial services companies, it turns out, were not using flash. So the technology has penetrated this sector fairly well. Among large financial services firms, a full 95% are using flash memory at this point. And about half of these big companies have more than 5 terabytes of flash memory deployed. These are substantial numbers, and again, it's not too surprising considering the kinds of work that they're doing. Among smaller financial services firms, we found that about half have 500 gigabytes or more of flash installed, and about 13% of the smaller firms are up above the 5 terabyte level. So there's some fairly heavy usage there too. Another question that we asked was about tier 0, what we call tier 0 storage, which is automated placement of data deep inside the server in a cache, very close to the processor, very speedy access, and with an automated component that's moving hot data into that flash and staging data automatically. And this is some kind of technology that the financial services companies, again, are the leaders. About 60% of those companies said they were using this kind of tier 0 storage, and only 25% are not. So it looks like that kind of idea has caught on quite well. I suppose it's very useful in things like algorithmic trading and high-frequency trading. Among the non-financial services companies, 31% are using tier 0 caching, and 44% are not. So there's some room for growth there, and perhaps these companies will learn from their cousins in the financial services sector. We asked also what kinds of applications are companies using flash-based acceleration for, and not surprisingly, the biggest applications, most named applications, were virtualization of servers and storage, and also business intelligence. Business intelligence, you can see any kind of analytic processing is going to use a lot of data, and virtualization, of course, has a lot of memory swapping going on, and so there's a lot of potential there. Approximately just below 50% in both of those categories were using, 50% of these companies were using flash in those applications. Not really a big surprise. Another obvious use of the technology is in transaction processing, database management, and you can see some of the data here. There's not a whole lot of surprises here. Finally, we asked about the budget for flash storage. It turns out that the budgets will probably be about the same depending between both larger firms and smaller firms. Just over 50% will increase their spending on flash-based storage. And it turns out that you don't see it here, but the biggest users of, or the biggest applications for this technology will be virtualization again, big data analytics, and business intelligence, all being planned for by more than 50% of the companies. The big growth sector, or the big application that's really going to change over the next 12 months appears to be the virtual desktop infrastructure, or VDI, which will go from being the 8th most listed technology or application up to number 4 over the next 12 months. And that appears to be the most biggest change that we'll see. Close behind, surprisingly to me anyway, was video and collaboration. These are apparently able to take advantage of flash memory as well. And I should mention too that the virtual desktop usage is being seen, or growth in that area is being seen in both smaller firms and in the larger firms equally. And I think now we have, we'd like to push out a poll that we could show you. Please think about the question here, which is basically, what are the top 2 storage concerns related to your data center? And the options to choose are storage capacity sprawl, application database response time, virtualization across multiple centers, disaster recovery, remote, high availability, which is different from disaster recovery, more local, and finally, continuous power, cooling, and space costs in the data center. So please register your vote. You can choose any 2 of these as the top ones, and then hit Submit Answer, and we will collect the answers and run them through our flash memory big data analytics machine here and tell you the results in a few seconds. But please go ahead and tell us your thoughts on this question. Should mention that one of the discoveries of the survey was that C-level executives are trying to make more decisions on hard data, and that seems to be driving a lot of the use of flash in business intelligence and analytics, where there is a fair amount of data to be moved around and analyzed, and that's one of the sort of propelling factors. Everybody's voting? And do we have an answer yet? Do we have a poll? Okay, here's our results. Turns out that storage capacity sprawl is at 40%, exceeded slightly by application database response time at 47%. That's pretty close to what we found in the survey. Virtualization across multiple centers, 23%, disaster recovery, 13%, high availability, 28%, continuous power, 15%. Okay, well, thank you very much all for doing that. I think next we will have George Crump telling us about what SSD, solid-state disk, can do for us all. George?
Thanks, John. Appreciate that. That was an interesting result. I was glad that most of the people were concerned about application performance, so we're going to jump into that. One of the things that I want to do is talk about how to know you're ready for SSD. Even though we have a large group here that, depending on which class you're in, that may already have SSD, how do you know? You can think of this as, how do I know I'm ready for more, or how do I know which applications to move to solid state next? So that'll be kind of our goal there. Just some quick background on us. We're an analyst firm. We focus, as you might pick up from the name, on storage, and then as a result of that, the underpinning cloud and virtualization components of that. We do a lot of work, internal testing in our labs. We do a lot of real-world implementations or ride-alongs with end user deployments. We're involved in a huge server virtualization and desktop virtualization project at a large, interestingly enough, large financial services company right now. And then, of course, a lot of work with suppliers and of the technology, both in their labs and ours, and just conversations. So that's a little background on us. Let's kind of talk about what we're thinking about for a goal here for SSD. I like to frame up things of what are we supposed to do with this stuff. And if you think about it, you've got three basic things we want to accomplish. We want to make things respond faster, OLTP, analytics, things like that. The analytics is very interesting in this space because, in general, the more information that you can process in a shorter period of time, the more accurate predictions you can make as a result of that. So whether that's stress testing, a simulation on a bridge, or deciding which products you should ship to which area of the country on which day, it's sort of the same thing. And the more information you have, the more frequently you can ask those questions, the more accurate you can become. So clearly solid state plays a role there. The other thing is the increasing density in both virtual server and virtual desktop environments. I spent a lot of time talking about, in fact I was in, of all places, Anchorage, Alaska yesterday, talking about density, designing very, very dense virtual environments where we're trying to now move virtual machine counts into the 50, 75, 100 virtual machines per host world. How do you do that? Well, Flash and SSD play a big role there, and so we talk about that. And then finally, really to kind of lighten the load of the existing architecture, because what we see is, thanks to OLTP, analytics, and the various virtual environments, we can generate enough front-side data, if you will, to justify, in many cases, an investment in the back-end Flash, and it's that network in between that kind of becomes a problem. So we can actually use Flash to make the network less of a problem as well. So we'll talk about a couple of those things. So so one of the big challenges we see with SSD, either in initial adoption or broader adoption, is there's a constant fear over, okay, I'm going to pay extra for this storage. How much bang for my buck am I going to get, so to speak? I don't mind spending a little extra money as long as it's going to pay off. And so how do you know that investment's going to work for you? So that's a key thing. How do I implement this without having to re-architect my entire storage architecture? Our architecture or infrastructures tend to be more glacier in their design. They move very slowly. It takes a long time to upgrade them. We still run into a lot of 2 gig fiber channel environments and many 1 gig IP Ethernet environments. So that move up the stack to the next generation of bandwidth takes a while. So how do we do things without necessarily forcing an unnatural act, if you will, in the infrastructure? And then finally, how do we kind of balance the cost and performance? So we'll talk about some of those. So let's talk about how you know you need SSD or you need more SSD. What I generally find in a survey like John shared, when we have a high percentage of SSD, is most of the time, most SSD will do something. You can almost, I've seen very rare cases where where you implement SSD and there's no benefit at all. It's very, very rare. But most of that benefit initially is the benefit of reduced latency, not necessarily increased performance. We're just not waiting for things to rotate anymore. And then the second thing, as you kind of look at SSD, so I guess the point of that first bullet is you can almost arbitrarily implement SSD and see some performance improvement, and that can be a good thing and a bad thing. The other thing to look for to keep things very simple is CPU utilization. I have a simple rule of thumb. If you have CPU utilization up around 60%, you probably don't have an I/O problem. You have a compute problem. It's very rare to see data centers with CPU utilization that high. So anything lower than 60%, I tend to say, just go ahead and proceed and start investigating. So that's really the key issue. So then once we get to that point, then we want to start getting some details, right? So again, the first step is you can just put SSD in, see some improvement. You can start looking at CPU utilization. But now we want to kind of look at, do some real benchmarking and see where I can do things. So a CPU graph is really a good place to start. The next thing is to really start looking at some statistics, and I just pulled one as an example, which was I/O response time. This can also be queue depth, things like that. What you're basically looking for, though, at a consistent level is a wall, if you will. If you see where that blue line, that purple line is there on the slide. I'm not necessarily concerned where it is so much on the slide, but the fact that there's sort of a consistent wall that I'm being constrained with. And what that tells me is that I've hit some sort of limit, and generally that limit in a hard drive-based environment is the hard drive itself. So once you identify that, then you have a really good confidence level that the application could do more if it was given a faster responding solid-state device. So, and this graph right here is the after, right? So that before was a hard drive based, the application was writing to a hard drive, and now we're writing to solid state. And what you see as a performance difference is you can see that the wall has been removed, that the stretch between the IOs is much larger. And so that's an impact of the performance improvement in that environment. So the result is that you can see a much better response time as a role of the application. And the good news is that we were really able to predict that. If we look at this, go back to this graph again, you can see that there's that solid wall. We could look at that and know immediately that SSD was going to do some good things for us, and then once we put that in, we were able to see that. So that's really what you're looking for, and this can be done, at least initially, with pretty basic performance monitoring tools that almost every application, every operating system environment will provide you. But really, that's what you're looking for is sort of this wall effect. And so I look at, I try to keep things simple, and so I'm looking for three key things. Number one, I can work off of the general philosophy that almost any SSD will benefit, and then number two, I'm looking for environments where CPU utilization is really low, but performance is, people are complaining about performance, and that tells me that the CPU is waiting on something typically, and that something is almost always the storage. And then finally, in the statistics area, I'm looking for that kind of wall effect that we just kind of described. So the next process then is to sort of ease the SSD implementation. One of the challenges we've seen with SSD is there's almost a sort of natural thought that I've got to do this massive infrastructure upgrade. And as I said earlier, infrastructures tend to be a little bit more glacier in their movement up the bandwidth path. So it's just a lot of things that change. So what we tend to recommend is that people look server-side first. I'm a big fan of server-side solid state, specifically PCIe-based technology, for a couple reasons. Number one, it's a very surgical strike on performance. It puts the high-performance media right in the server where it's needed. I eliminate kind of the variable of the network and things like that I have to worry about. In many cases now, these devices are bootable, so I can boot right off of the PCIe card. I don't need to go to a legacy storage device or infrastructure to boot and then start paging back. And then from a use standpoint, I like to do two things with that server-side cache, and how you do this will really depend on which of those categories you fall in as far as an application. Is it virtualization or is it a database? But in general, I like to use a portion of the PCIe SSD as a cache, where basically as data is being accessed, it's being moved into the PCIe card, and all future requests are being pulled from there. That gives me, very, very fast response time directly down a PCIe channel. It's ideal for good read performance. It also helps write performance, because what happens is, even though in a shared environment, writes still have to go down the network, the storage network, the storage network, assuming that PCIe card is sized correctly, is almost solely dedicated to writes now, and so performance actually becomes better on the network itself. So that's a very good thing. And then this is all done automatically. I don't know an IT staff in the world that has more people than they know what to do with. Everybody's stretched thin. They're wearing a lot of hats, and they don't have time to babysit applications anymore. So the caching, because it happens automatically, makes life a lot easier. The other component that we like here is is to set aside a portion of this device for virtual memory where it makes sense. And this is especially important in the virtualized server and desktop environment. And we can use the SSD as a very, very high-speed paging area for virtual memory and get around some of the RAM issues that we run into in the environment. So next up, we want to focus on lowering cost and increasing efficiency. So we want to do, at the end of the day, solid state is at a higher price point than the equivalent, at least on a capacity basis, than the equivalent hard disk system. So we want to use that premium technology as efficiently as we can. So again, here again is another example why we think server side is a great way to go. It leverages sort of the processor or the server itself, I should say, to be the container, eliminating the cost of additional power supplies, connectivity, all those different things, right? It goes right inside server. We're sharing what's in there, and allows for very high performance. And again, we're placing the SSD right where the application is. So part of that is also we're not going to incur the cost of upgrading the network or upgrading the storage system down at the end of the network. So it makes for a very efficient deployment model as well. And again, caching comes in handy here because we can still leverage the storage network. Let's say the storage devices on the network are still hard drive based. They can be the sort of the long-term tank, and they can handle the write traffic for us, so we don't have to worry about risk of loss or anything like that. And the really key thing that we like about caching is it makes sure the SSD is used optimally at all times. It's one thing to go through and classify data and say, yes, this application needs to be accelerated, but that application doesn't need to be accelerated all the time. And so when it doesn't need to be accelerated, if it's just sitting there, if you will, idle on solid state, we're not being efficient with the investment. If during that time we could use that solid state for another application that could use the performance, let's do that. And so that's really what caching gives you a really good capability of doing. So on the use cases for the server side SSD, we kind of went through these. The database and John's graph, I think, really did a good job kind of categorizing these, and it really kind of ties into what we see as well. Again, the huge growth we're seeing now is the increase used in analytics and decision support, right? And again, it comes back to how many times can you ask the same question, and how much data can you consume to help answer that question? And the higher the consumption rate and the speed at which that question can be asked, either the more often you can ask that question or the more data that can be processed. And all of that leads to better predictions, whether it be for science or business or whatever. So that's a real big capability that we like to see used. again, in virtualization, I look at it as virtualization has always got this reputation of sort of being the term you may hear is I/O blender, because you now have some number of virtual instance on a host instead of the good old days, if you will, where we had one application, one host, one network card, and it was very easy to troubleshoot. Now we've got maybe 20, 30 virtual machines going down 2 or 3 network cards, and trying to determine which one is needing performance and which one is using performance can be difficult to ascertain. Solid state is ideal for that kind of environment because it doesn't have to rotate, so it can handle all this randomness with no problem. And again, even in a cached environment, it makes a big difference. And the same is true with desktop, right? The sort of the classic example is boot storms, but there's a lot of other things that we've seen in desktop virtualization that can cause problems as well. The other one that we see a lot of, and it actually came out in one of John's surveys there, was this sort of file share. It was the video point, and we're seeing a growth here. And what it is it's not necessarily that one person streaming one video is the issue. It's when the Avengers gets released and 600,000 people are watching it at the same time. At that point, it needs to be on a very fast type of media. And so that's where we're seeing that. So highly accessed data that is being accessed in highly parallel environments. And then the final area is sort of this storage appliance. We're really starting to see a lot of growth in what I call open storage software and hardware, where you sort of buy and I don't know if I like the term yet, but another term you're hearing is software-defined storage. But the concept of the data services that we've become accustomed to, like snapshots and replication and things like that, all being available in software. Well, that a lot of times you'll set up an appliance that runs that software and has storage attached to it. Putting solid state inside that appliance as its tier 0, which was another point that John had a graph about, really helps as far as overall performance and makes for a very high performance yet commodity type of solution. So that really, we've had a couple of questions come in that I'll just take real quickly. One is, how do I choose between PCIe cache and SSD? Which apps do best? The PCIe is going to be more the performance option. So I know that solid state is all high performance, but PCIe is sort of the next step up. And just because we have a better channel, and typically the board design allows for more flexibility and greater reliability. So SSD in a server environment would be more ideal for, certainly if all you needed was a boot device and then everything was coming off of a SAN. But anything where you're having a demanding application locally, especially if you're going to be doing virtual memory pooling, which was something I talked about earlier, that's something I would definitely use the PCIe type of solution for. And the other question I'll just take right off is I hear about flash having reliability problems, that it loses its ability to hold data over time. Is this a problem to be concerned with? Well, so the short answer is, if you buy your flash solution from a reputable vendor, answer is no. The longer answer is all flash memory has a endurance thing, in that you can only write to it so many times. There's 3 types of flash that you can go to, but in general, the flash vendor has controller technology nowadays that really mitigates most of these write problems. So it's not something I tend to be overly concerned with. I would just make sure that I'm buying from a reputable vendor that knows how to do that. So that kind of is my section, John. I will go ahead and pass it back to you and let you take the baton from here.
Thank you very much, George. That was very informative and very useful. I learned a lot. We just would like to, I'd like to just invite everyone online to please think up some questions and submit them. And we will be answering those in a Q&A session soon enough. And also, we have another poll out here that we'd like to ask you all about Flash. Flash obviously isn't everywhere, and I guess the question is, why not? It seems like an obvious thing. Add some Flash and get some performance, but some people have some questions and doubts and reasons for not rushing out to buy some Flash. So we'd be curious to know what's holding you back, if anything. Cost, is it reliability, implementation complexity, is it that you need more capacity, is it the application or database support, has it been tuned to Flash, and or perhaps you're just not sure of how it will actually improve performance for your particular apps. So please vote. I think in this case there's just going to be one thing to choose from. So please vote. Cost, of course, is coming down. Reliability is improving. Implementation complexity. And we have our answers here. Cost seems to be still the main thing with about 40% concern, followed by performance uncertainty at about 21%, 19% reliability concerns, need more capacity 14%, application database support 7%, and implementation complexity 2.3. We'll call that 2%. So I guess cost is still something that some companies, enterprises have some concern about, but stay tuned. As with all semiconductors, flash memory is falling in price as we speak. Gina, you're next, and I'd like to introduce here Gina, who's from LSI, and will tell us about LSI's flash memory solutions.
Great, thanks, John. And one thing that that came up was about the reliability concerns of flash drives. And I'd really encourage you all to go to the LSI.com or actually the Smarter Way to Faster.com website. And we have a paper out there. It's called, it's on SandForce, and we have a feature called DuraWrite. And it really shows how we are able to really alleviate those concerns you might have about reliability. So I'd encourage you to go there. And then I think as we talk, you'll really understand that our particular solutions are a very cost-effective solution for your flash technology. And then also, I wanted to, thank George as well as John. I think they kind of created a great segue for me to talk about the Nitro acceleration solutions. So over the next slides, let's take a look at the performance needs and challenges that many of you are experiencing out there in the financial industry, and how the Nitro architecture was developed in really direct response to the challenges you're facing. And one thing, as George spoke about implementing SSDs without completely re-architecting the storage infrastructure, we'll discuss how Nitro is able to accomplish this as well. I think I need to give it a minute. Sorry if I'm a little slow. My system's a little slower. And so, the Nitro architecture provides the best-in-class flash storage solution. And we can take a look at these at a very high level. There's really three to look at. And kind of what George mentioned, really what do you do with this stuff? Let's just kind of get down to the nitty-gritty, what it is and what you can do in your own environment. So the first in our lineup and our offerings is we have the Nitro Warp Drive. This really provides the highest performance and lowest latency for the most demanding environments. So within a warp drive, the SSD, kind of as George was talking about, it actually resides on the PCIe card that is installed in your server. And this makes great sense, as the data is as close as possible to that application to really get that optimal performance. But there's other of us out there, we also maybe already have invested in the storage area network. And for that we have the Nitro XD, because you don't want to do a complete upgrade forklift of your infrastructure. So with this solution, we use intelligent caching, and that writes data to flash. That accelerates the performance of the overall SAN, but you're going to be able to retain that investment in your SAN and those disk drives. So that's a nice feature as well. And then the third one is the MegaRAID. And many of you have heard of MegaRAID before. This is the Nitro MegaRAID. And we've seen a growing shift in the adoption of direct attached storage, in the data center and rack, et cetera. And being able to improve the performance is really critical here as well. So utilizing the Nitro MegaRAID with Flash is a great way to do this. And we'll get into a little more detail. And then finally, we have intelligent caching. Really here, I hope I don't sound like a broken record because I know this was covered just a little while ago, but specifically talking about there are solutions out there that George was talking about. So for our intelligent caching, we basically accelerate access to the data that you use most frequently, or what we call hot data. And the nice thing about our caching is that it doesn't require any major overhauls, and it's really pretty seamless introduction into your environment. So we're just going to get into a little more nitty-gritty about the products, but not too much, where people start to kind of glaze over. So, again, we talked about the Nitro Warp Drive, the one you see here to the left. And this is for databases where achieving performance is at an all-time critical high level, probably for many of you out there in the financial industry. And really replacing your existing spinning disks with flash SSDs residing within that server on a PCIe card is really the best way to accomplish this. This is a great way for applications where the data needs to be analyzed as quickly as possible, while it still has real value, while it's still fresh. So that's why this is important. And here the warp drive with flash, really as the primary storage, is the best solution for these extreme performance environments where they, I've even read before where they say even a millisecond delay in getting that data can result in lost revenue. And then as you see in the middle, the Nitro XD, obviously not all of our databases run on these environments. We talked about a SAN, whether you have iSCSI, Fiber Channel, or SAS. These typically run on traditional hard drives, and this is really becoming the bottleneck, as these drives just can't keep up, with the performance required of your database applications. And if you've, listened to any LSI presentations in the past, you'll often hear this referred to as a data deluge gap. And as we mentioned, most of us can't afford a total upgrade of our SAN, nor do we want to. We still want to be able to use our high-capacity, cost-effective drives that are still available to us. But we still want to accelerate our performance, and we can do that with the Nitro XD solution. Again, this uses caching intelligence on the flash. That go ahead and then eliminates the bottlenecks on the drives. And then one thing we talked about is that, we really want to retain our investment. And so what you can do with the XD solution is that you can also operate that cache in a write-through mode. So all that data is still written to the disk drive, so you can retain all your SAN features. So if you want to take advantage of replication, snapshots, remote mirroring, you can still do that with this solution. Kind of really getting the best of both worlds here. And then finally on the right, as I mentioned, many of us are currently using or moving to direct attached storage for some of our environments. And so for DAS, we have the Nitro MegaRAID card. And then, it combines the high-performance flash, the caching intelligent, and then what you also get is LSI's industry-leading RAID controller onto just the single PCIe card. So, and this is really designed for cost-effective implementation. So you get a great all-in-one solution, very simple and very cost-effective for you. And I'm waiting for the slides to change. So, and so while I'm hoping that it will change, we can talk all day about, how great the Nitro solutions are, but it's really important to see some real-world customer experiences with the Nitro offerings. Let's cover some of these now, and let me try to change the slide again. All right, I think the third time's the charm. We're going to make it happen. Okay. So here, the specific customer we're talking about, they're called Green Power. They are a leading supplier of nutritional supplements, but they have a lot of the same requirements that a lot of folks in the financial industry do. They're really challenged with their analytics, and they were really struggling with being able to deliver the information they needed quick enough to their employees or their customers. So, either their customers aren't being productive, I'm sorry, not their customers, their employees were not being productive, or on the other end, they're losing revenue by their customers. So what they try to do in the beginning is, as you can see in the top picture, is they try to solve this problem with a bunch of SSDs. And what it really did is it was kind of a hodgepodge, because unfortunately there was no caching, there was no intelligence, and these SSDs really just created additional single points of failure within their infrastructure. And while it did improve performance and response time some, they still weren't getting what they needed. So what you see here in the image on the bottom right-hand corner is what they introduced is a large capacity nitro warp drive. This really improved their performance by 50%. I mean, that's a pretty staggering number, and that allowed them to make the intelligent decisions faster that they needed to, respond to their customers more effectively, and then also what they found, it was a lot simpler to manage versus the multiple SSDs that they used to try to solve the problem in the first place. And we'll go on to the next one. Okay, and so for the next customer scenario, we're not going to be able to actually mention the customer. We have a lot of great customers, but not all of them want to be in the spotlight, that they had an IT issue. But for these guys, we could share that they were a financial company, and they were really challenged with supporting a high number of customers entering their portal in the wait time these customers would experience, so causing a lot of frustration. And we did a study on this that really kind of hit home on this issue, and we termed this as the 3-second response time rule. And this rule really takes a look at how long a user would wait before abandoning a site that was unresponsive. I mean, we've all been there and done that too. And that time is 3 seconds or less. And then you make the matters even worse is that 79% of those users who were dissatisfied, frustrated with that website's performance, really never returned to the website at all. So, the stakes are really high when you're looking at a situation like this. And this financial company specifically was using disk drives via SAN, and there was really a limit to the number of customers who could access specifically a stock portal and not experiencing any latencies or these wait times. So the solution that they implemented was the Nitro XD. And in this case, they were able to really increase the number of users that were happy because they could simultaneously access the portal without the wait times. And this was up to 3.5 times more users in this case. So you really can see the improvements, with the Nitro XD can be pretty significant. We can talk all we want about speeds and feeds, but at the end of the day, it's, the customer experience, the productivity of an organization, and the Nitro solutions are able to accomplish that. And now we're not going to look at specific customers, but more of environments. We talked about virtualization in some earlier slides, actually, that George has. And there's some direct benefits we can have here. And first, the most obvious benefits of virtualization itself is a great way to improve server utilization, ROI, consolidation, and the list goes on. And this is really done by increasing the virtual machine density at each server. But the problem here is that when you load additional VMs on each server, that can really show itself really quickly in terms of I/O performance. So when we looked at virtual databases, even if you have a lot of sequential I/O, that sounds great, but as you add more VMs, the storage traffic becomes more random, and there's a really good chance that you might be paying a penalty in performance and really taking a toll on the hard drives and a SAN if you have such an implementation. But by introducing the Nitro XD, you can really improve response time by caching the hot data in the actual server, and this alleviates much of the bottlenecks that were caused by virtualization. So you want to take advantage of virtualization, but you don't want to have negative impacts of implementing such a configuration, and the Nitro solutions help you remove those. And the next one we're going to take a look at, and we're getting close, this is just our last environment to take a look at. And finally, one of the things we're seeing growing demand in is big databases like Hadoop. For example, many search engines and financial firms, like some of you out there, are using this technology to be able to analyze and calculate large data sets. And I am no expert in Hadoop whatsoever, so I'll kind of cover this in general terms. But Hadoop is a framework, and that you're able to build out applications on top of. And this creates a great platform for developers to write applications while also using low-cost commodity clustered servers, drives, etc. And at a very, very high level, I'll kind of go into the process, the Hadoop process. And it's really just 3 steps. So you see on the top, the first phase is mapping, in which you're really creating structure. So for example, this would be the same as taking raw web pages as input and then assigning the source link and a destination. And then number 2, this is called shuffle and merge phase. Or shuffle and sort and merge. And in short, this really brings all the source structured data you want together at a single location. And then number 3, that last phase is reduce, and really what you're doing here is querying all the data. And then, and I should have stepped back just a bit, but number 2, the shuffle phase is really critical. It's very IOPS intensive, and we really think this is where Nitro solutions play very well. And this is kind of an eye chart you see below here. But what we did is a demonstration in one of our labs and compared really 3 work nodes on a test called TerraSort. And which we did is run a Hadoop job with these following steps we just talked about. And this test was ran 3 times. 2 times with different drive quantities and once with the Nitro MegaRAID. And as you can see here on the left, it took 222 minutes to run this TerraSort test with a single drive. And then we increased those drives to up to 20, and you got that job down to 32 minutes, but then you got to think of, okay, I'm adding all these extra drive, cost, heating, power consumption, et cetera. So that's something to consider as well. However, when the Nitro solution was added, we were really able to reduce this time to just 11 minutes. And that's pretty significant. And also it's a much smaller footprint. And if you look at it overall picture, it really provided 20 times faster performance for a Hadoop database. And one thing before we kind of finalize is I think it's really important to talk about a really cool tool that LSI has, and that's our LSI Nitro Predictor Analysis tool. And then you say it's easy as kind of 1, 2, 3. And what it does is it uses intelligent caching algorithms, and these algorithms are really similar to what our caching software does. And it captures what data is frequently accessed, so the hot data on your production server. And I know people get nervous about using kind of analysis tools, but this is very non-disruptive, and it's really transparent to your OS. And so once you do that, from a non-production server or maybe even your laptop, the Nitro Predictor will report out and forecast, the performance benefits you can achieve, and identify the best Nitro solution for you, really making it easy to choose the right Nitro product for your specific workload. And then I would suggest, to get more information on this it's pretty an amazing tool. I would suggest to go to the thesmarterwaytofaster.com. And then I'm going to do my really quick recap, spiel. So, really, why LSI? I know many of you have heard of us, but why LS Nitro? And so, really the first important thing is that it's really fast. I mean, we're all talking about acceleration today, and that is what this does. It's the world's best flash management. It removes the latency. Your applications are no longer waiting for data from traditional storage, and you're really improving overall response time. And we didn't get too much into this today, but we have a fully offload architecture. So what the Nitro does, it does not tax your server CPU cycles at all, and really frees them up to really do their job in processing applications. The next one, it's really smart. We talked about intelligent caching, especially with the Nitro XD and MegaRAID solutions. It really knows what data is frequently accessed, what needs to go on flash, what can go on your existing investment of drives. You don't have that user intervention. You don't have any kind of tweaking or tiering of your database needed. And then LSI, we were a trusted partner. We've been around for 30 years, developing storage technologies, for example, RAID and SAS, and the list goes on. Talking about, I'm a little concerned about, it came up before, using flash technologies. We have the DuraWrite capabilities to make you more confident in the flash technology, and we really use enterprise-grade flash technology as well. And then finally, it's pretty easy. There's the concerns that it's complicated to implement into your environment. And there's really not with the Nitro offerings. It really seamlessly integrates into your existing environment without any changes to your apps, your OS, or any of your storage. And then, as I mentioned, we really have a broad capacity of flashpoints, and we're pretty extensive OS support. So whatever you have, we can support that for you. So you're not having to, customize, adjust your environment for us. We've already done that for you. So again, it's really easy. But I think that's it for me. I want to thank you for just spending a couple minutes with us on the Nitro products, and I'll turn it back over to John.
Thank you very much, Gina. That was very helpful and very informative. We would like to invite you to stay with us for a Q&A session, but before we get to that, we have a number of good questions actually lined up. Before we do that, we would like you to fill out a feedback form, which I've just put up on the screen. You just press the Submit Answer button at the bottom of the page, and we thank you in advance for that. Your participation will help us, enable us to serve you much better in the future. And I will just speed things along a little bit here and get to the questions. We have myself, George, and Gina online to answer them. And I think the first question I will take is, are the LSI solid-state disks compatible with HP UX and Itanium processor-based systems? Does anyone want to take that, Jamin?
Sure. So this is Jamin, and we have support for a wide range of environments, but unfortunately it's on Linux, Solaris, Windows environments, so primarily the x86 and as well as Spark.
Okay. Next question, is it supported by Oracle in cluster environments?
Now, this is an excellent question, because that's, I assume, directed at the server-side caching, and is a common question about how to deploy something in practice. And there's a particular mode to take advantage of server-side caching within Oracle RAC that is basically what I would recommend. There's this software feature set in Oracle 11.2 that's called Smart Flash Cache. And what that does is it allows you to use a high-performance solid-state disk resource as a cache, a secondary cache after the in-memory cache to get higher performance. So there's a couple ways that you can do that. Oracle has their F40 card, which is a PCIe SSD that you can take a look at. And then there's also the ability to use Nitro Warp drives as well for different capacity points in the same feature set. The only requirements are to be running Oracle 11.2 or later, and to be running Solaris or Oracle Linux behind the scenes. And once you're doing that, though, this is a very, very easy way to integrate PCIe flash into the caching hierarchy, and that's more moving it on the memory tier than on the storage tier.
Okay, next question. Somebody asks, with solid-state drives, there seems to be an issue with degradation in performance due to trimming. Is this still the case with the newer generation solid-state disk? I guess, Jamin, that might be yours again.
Sure. So this is an interesting way to word it, and I think there's a couple of terms that are getting crossed. In general, SSDs, when they're placed into sustained random writes, have degradation in performance because internally there's a lot of block level management that's taking place to handle that. And so this is called basically preconditioning the drive and reaching steady state. And it's primarily for a random write type of workload. There's a couple ways that vendors have solved that. As Gina mentioned, there's the DIR-write technology that LSI has inside of our controller that allows us to dramatically reduce that effect. But across the board, that there's always some degradation. The second piece of this question is about trimming, and I'm going to assume that's related to this spec that's been developed for a trim command to SSDs. And this is kind of an exciting time as software is catching up with the new things that hardware can do. And what trim does is, rather than the way normal file systems behave, where they just delete inode indexes and leave the data on the device as is, a trim just notifies the device that certain LBAs are no longer referenced. And that's a standards-based approach to also reduce this degradation in write performance. Because the amount of free space within the device, it basically dictates how much the performance will degrade. I would highlight, though, that reputable vendors are going to publish their performance after steady-state preconditioning, and the performance at these levels is still very, very high. And so lots of times you just have to see, are you looking at fresh out of the box numbers, or are you looking at preconditioned numbers? And the preconditioned numbers are still very high.
Okay, thank you. Just one last question, which I will be able to answer, which is we pushed some numbers at you earlier in this presentation about the financial companies and their use of flash, and we talked about some of them having more than 5 terabytes of data and so forth. And somebody was wondering if we could supply any information about what percentage of their total data is actually on flash, and I'm afraid we can't. That's just unfortunate, but we don't have the answer to that. I think it's about time to wrap things up right now. Thank you all for being here. We would like to invite you all to join us and continue the conversation at the website datacenteраcceleration.com, which is our community focused on all things performance related, not just solid-state disk and flash memory, but everything else. But we will be talking about, we do talk about solid-state disk and flash a great deal there. Please join us there and join the discussion. We have bloggers from the industry and experts from around the industry and users like yourselves and so forth talking about these things in writing, and we'll have more chat sessions and things like that. Also, within the next 24 hours, please expect to see a personalized follow-up email with details and a link to today's presentation on demand, and you can also view the on-demand event at datacenteраcceleration.com. So thank you again for attending today's webcast, Intelligent Flash, Helping Enterprises Apps Run Faster, brought to you by Data Center Acceleration, Information Week Financial Services, and LSI. The webcast is copyright 2012 by United Business Media. The presentation materials are owned by and copyrighted by Information Week, Storage Switzerland, and LSI, who are solely responsible for its content, and the individual speakers solely responsible for their content and their opinions. On behalf of our guests, George Crump and Gina Geisel, I'm John Verity. Thank you so much for your time, and have a great day.